Welcome to the Target Course Introduction to Wing Design. My name is Brandon Litherland, and in this video we'll be going over the basics of wing design, including how to manipulate your planform sections, how to manipulate sections themselves, how to change the various parameters of your wing according to your calculated values from your project, and then how to change your airfoils, how to deal with wing placement, and then finally how to scale your model so that you can make a 3D print file at the end of the video. So to begin, if we click on our wing, we'll have a placed wing in here. I've already set some values that make it a rectangular wing. I've shaded it so that you can see the surface reasonably well. I'm just going to jump to a top-down view so we can start talking about some of the parameters that change in here. Now I want to quickly mention there's a difference between a planform value and a sectional value. If you click on the Xform tab and turn off planar symmetry here, you'll notice that the section that you're controlling is actually only here on the right hand side. VSP is automatically calculating and creating the other side of the wing for you, assuming that it wants to be reflected about the center of the vehicle. So that's pretty handy, but it does make calculating total planform and section planform a little bit different. So in total planform, these are the values that you're going to be checking according to the values that you've calculated in your project. So things like your area and aspect ratio, your span, etc. is all going to be checked in this tab. You can go in and control the different parts using these sliders and values, but it's recommended that you control all of this stuff from the section tab because that takes a lot of the guesswork out and VSP isn't going to be making assumptions for you. Now, from the section tab, if you look, we have an aspect ratio on the right hand side of 5 and an area of 80. With a constant taper ratio of 1 to keep it rectangular. On the planform side, we have a span of 40 and an area of 160. That's because the section side is only calculating the aspect ratio and area for this side. Planform includes the entire wing. So when you're trying to input the values in the section from the values that you calculated from your project, just divide the values by half and you'll be able to put these in and everything should come out fine. If you need to check, by all means, click on the Plan tab and make sure that these make sense. So, we're going to go into a little bit of how to modify this part, starting with you can add or subtract sections to your wing if you choose to do a multi-section wing. You can do this by splitting. You'll notice here on the right-hand side you have two even sections now. If you go out and click to the next section and choose Insert, what that does is it drops a new section into the wing right here on the outside. So that's a few different ways to make a multi-section wing. Right now we're just going to cut that part off. We'll cut that as well. Set the aspect ratio back to 5 and now we're all set. So you'll notice that I was changing some of these values by typing in or moving a slider around, and there are a number of ways that you can do this. So if we change the view just a little bit, you can double click or just click, change the number, and your model will change accordingly. But if you don't already know what the value you're looking for is, you can also just grab the slider and move it around. Now notice we're changing aspect ratio here. So area is staying constant, your taper ratio is constant, but your span is changing. So because only 3 of these different controls can be active at one time because all the equations are linked together, VSP will only allow you to alter 3 at a time. So you notice that you have calculated area and aspect ratio. Span is derived from those two. You can't control it. If you would like to use span instead of area or aspect ratio, you can click on one of the radio buttons and it'll let you set it accordingly. But if this happens to be jumping around or it's difficult to control and it's a little bit too rough, you can click on these outside brackets and what that will do is it'll collapse the range of this slider. Now if we move it, you'll see that it's a little bit of a smaller change when we move the slider. Let's click on it a lot and now watch. You can hardly tell that it's moving, but if you look over here at the number, it is. It's just a very, very small range. Now, if you go all the way to one side. You see how this button has changed. Clicking on this now lets you expand how far this goes. You know, it goes farther and farther and farther. Eventually, you try and approach 0 and you cannot go that close. There is a minimum value that you can set for some of these. That vertical line says you have to stop. So let's move this back out, make it about an aspect ratio 4 or 5 wing. And now we're going to go over how to actually start controlling the individual values that you calculated from your project. Okay, so let's go back to our section tab and start playing around with some of these settings. So you'll have calculated the area that you need for your wing inside your project. Let's say, for an example, that you want an area of 100 square feet for your wing. Well, because we're working with the section, we'll want to set this to 50. You'll notice that if we check in plan, our total planform area is 100, and it's right where it needs to be. Great. So now you'll have also calculated the aspect ratio. If, again, you've decided that your aspect ratio wants to be something like 10, then you want to set the aspect ratio of your section to half of that at 5. Let's check the plan again. We've got an area of 100 square feet, an aspect ratio of 10. And now we go back in the section. Again, area and aspect ratio will automatically calculate what the span is. So right now you don't have control of that. If you would like, click on the radio button and you can set the span, and the other value will be calculated. So now that we have discussed how to change those values, you might notice that some of this still looks a little bit odd. For example, if we cut this part out, add the default wing back in, this is probably what you're looking at when you first start your project. So if we go back to section and we want to change aspect ratio, area, and then leave, say, root chord, you have an aspect ratio of 5, you had an area of 50. That looks like a pretty weird wing. Now, to control the actual planform, there are a few other things that we need to adjust, namely the chord and the sweep. So by default, VSP assumes that you want a 30-degree leading edge sweep. Sweep location means where along the chord the sweep is controlled. If we move this slider to the back, move this away. If we move it to the back, it says that I want 30 degrees along the trailing edge. If we move it forward, it's 30 degrees along the leading edge. So if we set that to 0, now it's a little bit more clear. 0 leading edge, 0 trailing edge. Now a common place to adjust the sweep is either about the leading edge, or if we type 0.25 for the quarter chord, that's also a very common place to put the sweep angle. Now the other part, when we're talking about chord, you'll notice that we're able to control this value only so much. You see how out of the tip it's gone to 0 because we've asked for too much chord down at the root. Now aspect ratio and area are still 5 and 50. In plan form it's 10 and 100, just like we asked it. But this is changing how everything looks. A better button to control is likely your taper ratio. So if you know that you want your tip chord to be a little bit smaller than your root, you can say, I want my tip chord of this section to be half of what the root is. Now everything is set for you. You see, that's a much nicer looking wing. So keep that in mind while you're adjusting these things, that in order to make the planform that you want, you not only need to know area and aspect ratio, but you'll also want the sweep angle and either the taper ratio or the root chord. So now that we've discussed that, we can go down and start talking about dihedral. So if we choose a front view, right now this wing has 0 dihedral. If we choose to bring that up a little bit, positive dihedral makes it do that. You can choose anhedral or negative dihedral by making this negative. If you have something like a gull wing or a multi-section wing, you will set the dihedral for each of those different sections. Now, if you choose to rotate the foils to match the dihedrals because you choose to add winglets or something like that to your model, be very, very careful to make sure that the dihedral here in the middle is 0. That can cause some problems when you're trying to write your STL. So we'll mention that again when we start talking about our 3D print files, but for right now, you shouldn't have any dihedral high enough for this to matter. Leave this button off. Okay, now that we've discussed that, what we're going to do is go and look at some of the resources that are available to you to find airfoils, find the DAT files, and how to read those files in to an OpenVSP model. So we'll go ahead and look at that next. Here we're looking at some of the resources to look for airfoils for different aircraft and how to find the actual airfoil files to read into VSP. So the first source that we talk about is a list of several different aircraft and the known or suspected root airfoil and tip airfoil for each of these. So if you happen to know what your example aircraft is or are, you can find them in this list, determine what their airfoils are, and then figure out whether or not you want to use a similar airfoil or something a little bit different. Now, if you go to the airfoil data site, you have a directory of all of these airfoil files. You notice that most or all of them are in a DAT file, and you have GIFs of the different images so that you can actually click on one. It'll bring it up and show you what the airfoil plot looks like. Let's just back up. So you have some Boeing files, you've got Cessna and a bunch of NASA files and several different things, but the point is that they're all here. And if you click on one of these, you'll see that it brings up the coordinates, and these can be used to read or convert into a file that's readable to OpenVSP, and you can drop these points straight into your model. Another very useful site is the airfoiltools.com database search. So you can look for the name of the airfoil, or you can browse over here on the left. You can search for different types of foils and set parameters if you happen to know them. But this is covered in a little bit more detail in your handout. The point is that these are the 3 different websites that you're going to be looking at while you work with airfoils in VSP. Next, we're going to go back into VSP and talk about how to actually change the different parts of the airfoil. Here we are back in VSP, and if we click on the airfoil tab, you'll see that we're looking at airfoil section 0. If you click again and go to section 1, because this is a single section wing, it's the next section. We can probably get a better view of what this is all doing if we choose a wireframe view. Now, again, we go back to the root airfoil. By default, you have a NACA 10. Now, all this means is that it's a symmetric about the chord, thickness to chord ratio of 0.1. Again, we move this around. You can change the thickness to chord ratio. You can change the camber and the camber location. This is going to change these numbers that are designated in a NACA 4 series airfoil. Now, I've provided a link to some information that describes what the different numbers in a NACA series airfoil actually mean. So if you find that you need a 6 series airfoil, you can pick the first number designation here in the series. You can adjust your thickness to chord ratio. You can adjust your ideal CL. You can also type these values in if you happen to know. You can adjust your transition step. And you'll notice that all of these are changing the value of this name. So if you have an airfoil file that you want to read in, great. If you don't, you can still approximate that by moving these. There's this show button here that also gives you a little graph or a plot of what the shape of your airfoil looks like. So let's go into a little bit more detail here and look at how this airfoil is actually changing. Some of you may want to use these NACA 4, 6, or 5 series airfoils. Some of you may have a useful airfoil file that you want. Notice we click on airfoil file there in the drop-down menu, and it made it a circle by default. Let's go to read file, and just as an example, we're going to choose airfoils that are already packaged with VSP, and let's use a Boeing 737 section C airfoil file. Click accept, and it's changed it Now, you show, there's that foil, and you don't have any control any longer. The foil is controlled by the points inside the coordinates. So it is set to be exactly what the airfoil file told it to be. So you can recreate the airfoil section of a known wing parameter just by reading that file in. Sometimes when you try and read the files that you get from the airfoil database sites, it will crash OpenVSP because it's not in the correct file format. This goes back to my original point. Always, always, always save your model. If that happens and you can't find a file that works to give you the airfoil that you want, contact me or talk to your instructor and we'll be able to make an airfoil file that you can use. So don't feel frustrated, we'll get you taken care of. Next, we're going to talk about wing placement and finally how to scale the model for your 3D printing. So let's go ahead and work on that now. So let's talk about how to move this wing around inside your model. Right now it's attached at 0, 0, 0, and if we zoom in and look, you can see this green, red, and blue, which is hidden, point that indicates the origin of this part. Now let's make a copy of this, paste it, and you'll see that it's right on top of the other one. But let's say we want to move it a little bit in the positive X or aft direction and a little bit in the positive Z, and it moves it accordingly inside the model. Now the origin for both of these are in the same spot, so keep that in mind. But by moving these sliders around or choosing a particular value, you can place your wing inside the model. Now then, if we choose to move the Y, you'll notice there is a gap in the center of this wing. That's not being calculated as part of the plan form. So you can't say, well, I want, an extra 12 feet in between the middle of this to increase the span. It's not going to do it. The span is still 40 feet and the area is still the same. It's only calculating this part and this part. It doesn't calculate this. So anytime you're doing a wing, your usual best bet is to leave it set at 0 so that it's continuous all the way through. Now, we're going to go ahead and delete this part and go back to our first piece. We're going to mention briefly something about the difference between span and our projected span. Now, your span is the distance from here along the wing to here. That's how VSP reads it. In the section tab, you'll remember we put some dihedral into this, and in doing so, we actually changed where the tip of this part lies. So by giving more dihedral, we're bringing that wingtip in just a little bit. And this is an artifact of how VSP operates under the hood. But the point is that even with a little bit of dihedral, your span is still very close to what you intended, your area is still the same, and your aspect ratio is close enough to 10 that you should be all right. If you want to set it so that it is exactly the projected span and area that you want, you can go through and type in the span and area values that you want and keep doing that until it converges on the aspect ratio that you want to use. So, having said that, we're going to talk now about how to scale your model to either go from feet to inches, to set it to a particular size, or to change the scale to write it out for 3D printing. So let's go ahead and talk about how to do that. Now, in your handout, we've talked about scaling a component from, say, a 40-foot wingspan, which is what we have here. We can check the value in plan. And we want it down to 6 inches, or something that's more likely to fit inside the wind tunnel. Well, based on the math that you did in the example, we want a scale factor of 0.15 inches per foot. If we type 0.15 into this value and hit enter, notice our model shrinks in the viewing area. And now, if we go to our plan tab, here we are, our span is 6, our area is 3.6, and our aspect ratio is still the 9.9. Now you'll notice that when we scaled this, the same as what's described in your handout, VSP doesn't have any units. It's all a unitless thing. So we told it to scale from 40 to 6, but it doesn't care what you're starting or what you're ending with. That's entirely up to you. We know that we wanted a 6-inch span test section, but VSP doesn't know if you're working in millimeters or anything else. So you have to make sure that you're working in the right units and you're using the right numbers. Now, according to your project, you should be working in feet, which is what we just did. We went from 40 feet to 6 inches. Keep this in mind when you're doing that. If we go back to transform, you'll notice it remembers the scale factor. If you don't like it, hit reset and it scales it back up to full size. But let's assume that we like that value, everything looks good. We click accept, scale factor resets to 1, and now we have a 6-inch span. Our aspect ratio is good. Our model is now scaled in inches for how big it needs to be. So if we save this, we can now scale it again for writing out to a 3D printer. Now 3D printing software usually operates in millimeters. You can choose to scale the part in that software, or you can do it right here. If we go back to transform, we know that there are 25.4 millimeters per inch. Press enter. You'll see that we go to plan. We have 152.4 millimeter span. Aspect ratio is the same, and our area is now in square millimeters. So your model is now sized to slice up into an STL and export out into your 3D printing software. So now we've covered everything that you should need to know to design the plan form of your wing, set it up to write out to an STL file, and change the airfoils. So that's what we're going to cover next. We're going to go into writing an STL file and importing it into 3D printing software. We'll see you in the next video.